Assalamualaikum warahmatullahi wabarakatuh. In this part of video, I will explain about gravimetric analysis. So, what is gravimetric analysis? Gravimetric analysis is a method in analytical chemistry to determine the quantity of an analyte based on the mass of precipitate. Method converting an analyte into a stable, pure and workable solid by adding precipitating agent. Then the mass of the precipitate is calculated to determine the amount of the targeting substance in the analyte. So far, this method is the most accurate and fundamental method in analytical chemistry to determine analyte. So, how does this method work? This method consists of a few major steps, which is sample preparing, precipitation, digestion, filtration, drying, filtering, weighing, and calculation. There are some advantages and disadvantages from this method. The advantages of this method is it is the most accurate method in chemical analysis to calculate an analyte. It also requires low-cost equipment to undergo the experiment. It also limited space for making mistakes since a lot of step is reduced. It also no need for calibration because it involves of direct measurement. For disadvantages of this method, it is a very time-consuming method. It also can only measure one element in one time. Result of this experiment also can easily affected by environmental conditions such as humidity and temperature. And lastly, this method requires a relatively large sample.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muzammil bin Wan Mokhtar, and today we are going to talk about the gravimetric analysis or the procedure in doing the gravimetric analysis. As you can see here, this is the step-to-step of procedure of gravimetric analysis. We start with the preparation of the solution, precipitation, digestion, filtering, washing, drying, weighting, and lastly, calculation. First of all, let me introduce you to the apparatus needed to be used in gravimetric analysis. We need to have a weighting board, a beaker, and also a conical flask or Allen-Meyer flask. We also need to have a plate, desiccator, appropriate electrolytes, and also a wash glass. We also need to have a filter funnel, sample, filter paper, and also analytical balance. Now we are going to go into the first step of gravimetric analysis. There is the preparation of the solutions. First, the sample is being put on the weighting board. Then the weighting board is being put on the analytical balance. Mass of the sample is weighed accurately on the analytical balance and the mass is recorded. After that, the sample is being put into the beaker containing a distilled water. Then the solution is being stirred so that they become homogeneous. The sample is now put into the next step, that is the digestion. In digestion step, we heated the solutions with the hot plates. This due to the fact that we want to produce a larger and purer particle, so that the precipitates in the solutions go from colloidal to crystalline. And now we go to the next step. There is the filtrations. First, we record the mass of the dry filter paper. The filter paper is then being pulled in with the right techniques. Here we can see that the filter paper is being shaped into a cone shape. With these shapes, the filter paper can fit easily into the filter funnel. And then we take the solution from earlier and filtrate into the conical flask. We go to the next step. There is a washing. In the primary reason why we do washings with the appropriate electrolyte is to avoid peptidizations. It means we doesn't want the precipitate in the filter funnel or in the filter pepper to become colloidal again. Now we move to the next step, that is drying. First, get a dry and clean washcloth, and then carefully put or transfer the filter paper on the washcloth. Now, the washcloth will be put in the oven. The washcloth is then being heated in the oven for 24 hours in approximately 60 or 80 Celsius. And then after the heating, the filter paper is now being allowed to cool down inside a desiccator. This step is very important because after heating, we need the filter paper and the precipitate in that to become a normal temperature or room temperature. So that's the temperature will not alter the reading of electrical balance. Reason why we choose to cool it down inside a desiccator so that the moisture from the air or atmosphere do not intercept with or do not get absorbed by the precipitate. Now we go to the next step. There is a weighting. In this step, we record the mass of the precipitate and the filter paper on the analytical balance until we get a constant mass.
Hi everyone, so in this topic I'm gonna do some calculation question. So let's do it. The plant food that we use in this experiment is budgetary taman, and the percent of phosphorus content written on the label is 15%, and the mass that we use is 3.5 gram. The mass of magnesium ammonium phosphate is 0.535 gram. In first question, we need to find the mole of phosphorus in magnesium ammonium phosphate. So here we can see the mass of hydrogen and magnesium. And here is the mass of nitrogen, oxygen and phosphorus. So the molar mass of magnesium ammonium phosphate is 137.32 gmol. Next, we're gonna calculate the moles of magnesium ammonium phosphate. And the formula of moles is mass over molar mass. So the answer for magnesium ammonium phosphate is 3.896 times 3 power of negative 3 moles. So to get the mole of P, you need to use the moles of magnesium ammonium phosphate. So we need multiply the 3.89 times 10 power of negative 3 with 1. And we're gonna get 3.896 times 10 of power negative 3. So in this question, we need to find the moles of phosphorus pentoxide. So first, we need to find the moles of magnesium ammonium phosphate. So we're gonna get 3.896 times 10 power of negative 3 moles. After that, we need to find the mole of phosphorus pentoxide. To find the moles of phosphorus pentoxide, we need to take the moles of magnesium ammonium phosphate and divide it by 2. It is because it takes 2 atoms of phosphorus in one phosphorus pentoxide, and we will get 1.948 times 10 over negative 3. In last question, we need to calculate the mass of content percent weight over weight of phosphorus pentoxide in sample. We already get the moles of phosphorus pentoxide, which is 1.94x times 10 power of negative 3 moles. After that, we need to find the molar mass of phosphorus pentoxide. And the molar mass for phosphorus pentoxide is 141.95 gmol. Third, we need to find the mass of phosphorus pentoxide, which is we need to multiply the mole and molar mass. The answer we're gonna get is 0.277. Now we're gonna calculate the mass and content percent phosphorus pentoxide in the sample. So we need to divide the mass of phosphorus pentoxide with the sample mass. So the content percent in weight over weight of phosphorus pentoxide in the sample is 51.7%.